Good morning, students. In this section, we will see the derivation for ESX, ESY, HSX, HSY for TE and TM modes of a rectangular waveguide. And here, the derivations are done on the assumption that walls of the waveguide are perfect conductor and space between the walls are perfect dielectric. Okay. So earlier we have discussed on this matter in our first module, that is the walls or the surface of the conductor are perfect surface of a waveguide or a surface of a conducting medium will be a good conductor, while the inner surface will be a bad conductor. We already discussed it in our first module. Okay. So here we will start with the derivation. This is a typical rectangular waveguide. Here I have drawn the rectangular waveguide, and the walls, it is across that region, sigma, the conductivity is equal to infinity because it is a good conductor, and inside the rectangular waveguide, that is between the walls, the conductivity is equal to 0. Okay, I hope you remember the statement that electric field on the surface of a conductor will be maximum and electric field inside the surface is equal to 0. The same theory is used here. Okay, so we will start with the wave equation, that is del square Es minus gamma square Es is equal to 0. And for a lossless dielectric, you know sigma is equal to, that is a conductivity is equal to 0. Also we know gamma square is equal to j omega mu into sigma plus j omega epsilon. All these derivations were done in our second module. Okay, now what we are going to do is we are going to substitute sigma is equal to 0 in this expression, so that I will get gamma square is equal to minus omega square mu epsilon, which is my equation 2. Next, what I am going to do is I am going to substitute equation 2 in equation 1. So I will finally get del square Es plus omega square mu epsilon Es is equal to 0, and out of which this omega square mu epsilon is taken as k square, which k square is your wave number. K is your wave number, but omega square mu epsilon is substituted as k square. So I can write del square Es plus k square Es is equal to 0. Similarly, you can derive the expression del square Hs plus k square Hs is equal to 0, which is your equation 4. From that, you know k square is equal to omega square mu epsilon, and k is equal to omega square root of mu epsilon, which is your wave number. Now, suppose we are assuming that electric field has three components, ESX, ESY, ESZ, and H is equal to HSX, HSY, and HSZ. That means there will be 3 equations for electric field and 3 equations for H. So totally we have to solve 6 equations. Okay, here. So now first we will start with the Z component. So Z component of 3. This is our equation 3, and you know what is del. Del is equal to dou by dou x plus dou by dou y plus dou by dou Z, divergence. Okay. So del square means you can write it as dou by dou x square, dou square by dou y square plus dou square by dou z square. And if you substitute that in equation 3, you can write it as what? Dou square by dou x square ESZ plus dou square dou y square ESZ plus dou square dou z square EZZ plus k square into ESZ, k square into ESZ. We are writing the expression for the Z component of electric field, which is equal to 0. That is equation 5. Now listen, this is a partial differential equation. So to solve this, we will use the method separation of variables, which you have studied in your mathematics paper. So accordingly, we can write ESZ is equal to capital X of X, capital Y of Y, and capital Z of Z. That is equation 6. Next, what I am going to do is I am going to substitute 6 in 5, so that I can write what? Dou square dou x square of x, y, z. That is written here. Dou square by dou y square of xyz plus dou square by dou z square xyz plus k square xyz is equal to 0. Now I am slightly rearranging the terms. Dou square into capital X by dou x square into yz plus dou square y by dou y square into capital xz plus dou square z by dou z square into capital yx plus k square xyz is equal to 0. Now this dou square x by dou x square is your double differential. So I can write x capital X double dash into this yz here plus similarly y double dash into xz plus z double dash into yx is equal to, this term is taken to the right hand side of the equal sign. So I can write minus k square into xyz. The next step I am dividing the entire terms by xyz. So finally I can write it as x double dash by x plus y double dash by y plus z double dash by z is equal to minus k square. Next I am making a substitution that x double dash by x is substituted as minus kx square, y double dash by y minus ky square, z double dash by z gamma square, which is a phase constant. So what happens is this equation will become minus kx square minus ky square plus gamma square is equal to minus k square, where minus kx square minus ky square gamma square are separation constant. And we know here we have written x double dash by x is equal to minus kx square. From that I can write x double dash plus kx square x is equal to 0, which is my equation 7. Similarly, from this relation I can write y double dash plus y ky square is equal to 0, which is equation 8. Similarly, z double dash minus gamma square z is equal to 0 is my equation 9. Now the solution for 7, 8 and 9 is capital X is equal to C1 cos kxx plus C2 sin kxx. Similarly, y is equal to C3 cos kyy plus C4 sin kxy, and z is equal to C5 exponential minus gamma z plus C6 exponential plus gamma z. Here you are getting a different solution because the electromagnetic wave is propagating along the z axis. That is why in this equation you are having only the exponential term. Now, since the wave is propagating in the plus z axis, we assume that the wave is propagating in the plus z axis. In that case, this term will be equal to 0, because I hope you remember that if I have said earlier that if the wave is propagating along the plus z axis, then the exponential term will be minus and vice versa. So here I can write C6 is equal to 0. So finally I will get z is equal to C5 exponential minus gamma z. That is equation 30. Next what I am going to do is I am going to substitute 10, 11 and 13 in 6. That is this one, 10, 11 and 13 in which one? 6. Where is it? This, okay. Ez of x is equal to x of x, y of y, z of z. So because we have already found out the solution for capital X, capital Y and z, so that I can substitute Es of z is equal to x, y, z is equal to, instead of x I can write what? C1 cos kxx plus C2 sin kxx into C3 cos kyy plus C4 sin kyy, and instead of z I can write C5 exponential minus gamma z. The next step I am simply multiplying C5 with the terms inside the bracket, so I can write C1 C5 cos kx x plus C2 C5 sin kxx into C3 C5 cos kyy plus C4 C5 sin kyy into exponential of minus gamma z. Then C1 C5 is represented as A1, C2 C5 as A2, C3 C5 as A3 and C4 C5 as A4. So finally my expression is something like this. Okay. In the same manner you can find out the expression for HSZ also, that is B1 cos kx plus B2 sin kx into B3 cos kyy plus b4 sine kyy into exponential of e raised to minus gamma z. So right now we have derived the expression for e sz and h is sz in terms of a cos k, cos ky, sin k, sin ky, etc. etc. Now we have to derive other field components, that is the x component and y component of electric field and magnetic field. For that we have to use Maxwell's equation. So we will start with the Maxwell's equation. Del cross Es is equal to minus j omega mu Hs, equation 14, and del cross Hs is equal to j omega epsilon Es, equation 15. And del cross E means the cross product, that you can write it as determinant Ax, Ay, Az, dou by dou x, dou by dou y, dou by dou z, Esx, Esy, Eaz. That is equal to, the right hand side is j omega mu into Hsx Ax. This a cap represents a unit vector, plus Hsy Ay plus Hsz Az. Okay. Now what we are doing is we are taking the determinant and we will equate it with respect to the Ax coefficient, Ay coefficient and Az coefficient. Okay. Hence we will finally get dou by dou y of E z minus dou by dou z Esy is equal to minus j omega mu Hsx. This we will get when we equate the coefficient of Ax on both the sides. Similarly, equation 17 we will get by equating the coefficient of Ay on both the side, and equation 18 that of Az. Similarly, you can proceed for equation 15. Del cross H is equal to j omega epsilon Es. So del cross H, again the cross product Ax, Ay, Az, dou x, dou by dou x, dou by dou y, dou by dou z, Hsx, Hsy, Hz. That is equal to j omega epsilon Esx Ax plus Esy Ay plus Ez Az. Then next what you have to do is you have to take the determinant and equate the Ax term, Ay term and Az term, and finally you will get three equations by equating Ax, Ay and Az on both sides. Okay, the 19th equation you will get by equating the Ax coefficient, 20th one equating Ay coefficient, and 21st one by equating the Az coefficient. Okay. Now in the next step what I am doing is, from equation 17 I am writing the expression for Hsy, and that is my equation 22. Okay, and I am substituting equation 22 in equation 19. This 22 in 19. So I will get my equation 23. Okay. Now any variation of the field component in the z direction is due to the variation of the signal in the positive z direction. Okay. Therefore, now the variation of Esx, Esy, Esz and Hsx, Hsy, Hsz is proportional to the signal in the plus z direction. So I earlier told that the electromagnetic wave is transmitting in the positive z axis. So I can say these components is proportional to exponential of minus gamma z. So making use of that condition, I can write Esx is directly proportional to exponential of minus gamma z. So that is equal to a constant a into exponential of minus gamma z. And next what I am doing is I am taking the differential with respect to z. So I can write dou by dou z Es is equal to a into dou by dou z exponential of minus gamma z. Written as a into minus gamma into exponential gamma z. And so rearranging minus gamma into a exponential minus gamma z, and you know this term a into exponential minus gamma is equal to what? This is equal to Esx. So I am substituting dou by dou z Esx is equal to minus gamma Esx, which is my equation 24. Now what I am going to do is I am taking the double differential of equation 24. So I can write dou square by dou z square Esx is equal to minus gamma dou by dou z of Esx. So what is Esx? Esx into exponential of minus gamma z. So we differentiate, we will get finally plus a into gamma square exponential of minus gamma z. And you know this a into exponential minus gamma z is what? Esx. So finally I can write dou square by dou z square E Sx is equal to